We propose a data-driven gaze animation system using recurrent neural networks. Gaze is the direction of the head towards the target. Gaze shifts are the change from one target to another by rotating the eyes, head, shoulders, spine and hips. In games, gaze animations are regarded as a solved problem. Often, procedural animation systems are used to create these gaze animations. However, such systems are time-consuming to develop and quickly become complex and hard to maintain. Neural networks and deep learning for animation has seen a great increase of interest in the past few years. Neural networks are capable of learning a function from a set of examples. Recurrent neural networks feed back into themselves, which give them a form of memory. This enables them to learn from sequential data. We propose a recurrent neural network to mimic human gaze behavior. We recorded motion capture data of someone following a target with their gaze. Data was recorded for various poses, like standing, sitting, walking, and lying down. A head-mounted camera was used to film the face, so we could extract the eye direction. The recurrent neural network predicts the pose of the character in the next frame based on the gaze target and the current pose of the character. In our case, the pose consists of all central joints from the hips, spine, neck to the head and eyes. We also trained a simplified version of the recurrent neural network to be used when the character is farther away and allows for a lower level of detail. We only predict the hips, chest and head and interpolate the joints that are in between them. The recurrent neural network is capable of learning the gaze animations from the motion capture and eye data, resulting in smooth and natural movement. The simplified network is also capable of fluent movement and can do this in only a tenth of the time of the complete network. We have compared our proposed neural architecture to a feed-forward network, a stacked recurrent network, an encoder recurrent decoder, and a residual network. The feed-forward neural network and residual network were not capable of stable motions. The stacked recurrent neural network and the encoder recurrent decoder were able to learn the motions properly, but did not improve on our results. However, they do take longer to train and are more expensive at runtime. We compared our complete network and our simplified network to the procedural animation system of guerrilla games, as well as the ground truth motion capture data. We held a survey among game industry professionals, which shows that our method significantly improves on the procedural animation system. Our method has been trained to follow a gaze target, but has some issues when there are large changes in the target position. These issues could be solved by recording additional data covering these scenarios. If we want to cover additional poses, we can also record additional data. In summary, we present a data-driven gaze animation system using recurrent neural networks. Trained on a combination of motion capture data and facial capture, it is capable of natural gaze behavior in real time. We showed that our method significantly improves on the naturalness of the gaze animation compared to that of a hand-made procedural system.